what's the third book?
So then also we have an author, Sholmes.
Sholmes. He makes like the Cole's Notes of Math, doesn't he not?
Yes.
So
yes.
Why Sholmes? What's the big deal with Sholmes?
Because you also have to actually learn some basic mathematical concepts. Because in order for you to be able to think in the way that we need people to think, you're going to have to learn some kinds of, you're going to have to learn how, like principles, mathematical principles, right?
So in order to be the new black man in the Bredrins of common life will be an expert or well versed in the libertarian, no, not libertarian, the federal papers.
Federalist Papers, yeah.
Federalist Papers, thank you.
Mm-hmm.
So be well versed in the Federalist Papers. Mm-hmm. Be well versed in Plato's
dialogues.
Plato's dialogues, which are actually about Socrates.
Yeah, the life of Socrates. If you can become a philosopher in the same way that Socrates is a philosopher, you will be indestructible.
In addition to that, we need to have our heads wrapping around mathematics, so that we understand.
Even the philosophy, you're gonna have an easier time understanding the philosophy if you understand some of the basic math. Because from there's no separating those two things. Some people think that philosophy is one thing and mathematics is something else. They're not. No, math is derived from philosophy. That's why this book Mano is so important for you to listen to, because there's no pencils involved. It's just speaking. It's philosophical speaking, and it's through that philosophical speech that you see how mathematical ideas develop and how they're discovered. Because they do the discovery with you. If you go through this dialogue, you yourself will do the discovery too. So then you'll have that in your body. And the thing with us is human beings, we cannot tell the difference between an idea that we discovered and an idea that was discovered by someone else first.
Okay.
It'll be the same in your body. If you learn something that Einstein discovered and you go through the process in the way that he did, and not just memorizing the formula that he used, but you go through the act of discovery with him, you know what I mean? Mm-hmm. Then it's yours too. And now that it's yours, you have it can serve as like a stepping stone into like newer ideas, and you being able to understand a little bit of the lawfulness. Okay. You'll be able to project lawfulness or hypothesize lawfulness, right?
Right.
So yeah, this one here that I have is like strength of material. So that's more like an engineering book. I'm not saying you have to get the engineering, but yeah, he does everything. So you can do like, algebra, linear algebra, which is like kind of a calculus level math. You can do physics, all the different ones, right? But even if you're not going to go, I say Sholmes. The reason why I say Sholmes is because the way that he lays things out, you can literally read it like it's a book. You can just read. You can just read through the steps, highlight what you're seeing, right? And then and you can really get a grasp of it on your own. You don't necessarily need someone to walk you through it.
Okay.
Right. So, and if the Sholmes is not your vibe, there are actually plenty of YouTube teachers out there that you can learn from. One of the ones that I like personally, he teaches calculus. When you get to the calculus level, is Professor Leonard. He's a really good in-depth teacher, and he gets deep into the concepts. So that's really what you need to explore.
In what order do we have to become well versed in mathematics? Does geometry count? Does your simple,
trigonometry,
all
right?
right,
You want to learn triangles, angles, length of a side, things like that. Those are really the first ones that you want to get a hold of. And you may have to do some, depending on your own personal level, you may have to do other things. You may have to learn things like factoring, or I don't know your own thing, whether you'll have to learn long division, all these other things. After you've mastered arithmetic, right? Most people have mastered arithmetic, even dropouts have mastered arithmetic,
right,
but you have to get a level of competence in there, that you, not that you memorized a bunch of formulas, but that you understand the discovery of the formula. Because every formula that you see is like a discovery. There was some puzzle that didn't make any sense, and they were hitting their head against the wall, and then they finally found an answer. Like, for example, like Pythagoras' theory, right? That's basically, it's like Egyptians when they were building blocks, right? When you have three blocks and you're balancing them on each other, it's
right,
really like, how can you balance these three blocks? So what length do they have to be to stand, to lean on each other, right? But the relationships between the lengths of the sides is not really expressible, right? So then they come up with this formula. So it's sometimes a relationship between two things cannot be named. It's almost like the pi, right? Because that's like, you're trying to make a relationship between the radius and the circumference. So the thing is that there's no exact relationship between them. That's why you get a number that goes forever, is because it's actually the radius is 1, 2, 3, and a tiny little bit. And that tiny little bit is like an undefinable number. That's why you keep getting 0.14 and it keeps going forever. But that's what's happening. So sometimes when you have an undefinable number, you can square that number, and then it becomes a number that you can express. So these are the kinds of things that you're going to have to get a hold of, because sometimes you're going to have concepts that you're going to have to deal with in that way. Some things are not expressible directly. Sometimes you have to do something else to that concept in order to make it expressible.
Okay.
So that's with the why you need to deal with the mathematics, because also the world we're living in is a subtle one. So it's like it's not as simple as everybody wants to think it is. Because most of the time you're not going to be, you're going to be wrong. When you think you know what the thing is to do, you're going to be completely wrong. And if you don't have this kind of critical thinking, you're not going to be able to navigate the thing. And especially, you're not going to be able to create anything from your own, because the people you're battling against, they've mastered this. Right. So they can play the game. They can tell you that Socrates and Aristotle are the same. They can tell you that Galileo and Kepler are the same. They can tell you that Newton and Leibniz are the same. And if you can't tell the difference between Leibniz calculus and Newton's calculus, then you're not going to be able to tell when they're lying to you. And there's a big difference between those two. There's worldviews that back them up. We're all taught about Newton, and we're trapped because we're taught Newton. Right? If we could all learn Leibniz, then we can all be free. So this is kind of the world that we're in. I know this sounds kind of a little bit extreme, and it's hard to kind of get a grasp on what I'm trying to say, but this is the world that you're in. You're not living in a simple world. That's why we've been messed up for so long. If it was simple, the things that people have been doing forever would have worked by now.
Right.
But we keep getting dominated because we're not thinking outside of the box. We're actually thinking inside a box that is a prison. That within that box and within the axioms that we're accepting in that box, you can't find your way out of the box. It's like your brain requires to do a certain method, and you've convinced yourself that method is not useless, or that method doesn't exist. So the only way to get out is something that's not accessible to you.
Not acceptable to you.
Accessible.
Oh, it's not.
You cannot access the cures to your disease, because the cures are in a place that you either don't think exists, you don't think is useful, or you don't want to break your brain on trying to get there. And it's actually not going to break your brain, because the truth is, I was somebody that in high school, I wasn't, none of my math teachers were thinking I was going to be able to do any of that stuff, right? So it's not just like, it just takes hard work, right? But you'll be surprised once you start, the first time you discover something beautiful, and that's the thing with math, is that you're going to, if you actually go in it with a passionate heart and an open mind, you're going to find beautiful things in it. And the first time you discover your first beautiful mathematical idea, that's why I suggest Pythagoras is the first one. You can learn that concept, and when you really get that concept, you'll be like, whoa. And then you'll realize that, like, the power that's in that, you'll be like, holy shit, there's certain concepts that are actually bulletproof. There are certain parts there are things you can make that cannot be broken.
That are refutable.
Irrefutable. So you want to be able to create irrefutable things, but you have to know what irrefutable things look like in order to create them. You have to be familiar with their general composition. You know what I mean? If you want to make the car that runs on nuclear power, you have to understand the evolution of cars and what an engine does and why they have axles, or what the pistons do. Right. You have to know about combustion. If you don't know these things, you don't get to just jump from like, I don't know anything about it to like, I'm going to make the new version of the Ferrari that's faster and lighter and whatever, right?
Okay.
You have to know, you have to go through the evolution, and then you can add that new thing because you know what it's resting on. What's the ground, what it's grounded on.
Okay.
Right?
Okay.
I've been down this road before, but now